All right. I'm Sara Iverson. I'm a professor of biology at Dalhousie University and the scientific director of the Ocean Tracking Network. And I've also had a long history of work on marine mammals. Historically, estimates before Northern European colonization of North America, estimates are that most of the seal populations and species were at higher levels than they are today. The issue of addressing a question of whether any of those species are overpopulated is a really difficult one because, in fact, in comparison to historic levels, they are not higher than they were, and in fact, in many cases, they're much lower than they were. But humans have drastically altered ecosystems so that the interactions may have changed. I think first and foremost, the really critical point is that marine ecosystems are extremely complex. And there are so many species interactions that it is almost impossible to ever have just a two-species interaction of a certain seal species eats a certain prey species. We humans have vastly overexploited almost every ecosystem we've touched. We have overfished. One really good example is the overexploitation and overfishing of the Atlantic cod in the Northwest Atlantic. We caused complete collapse of that population, which triggered an entire change in the ecosystem. Those predatory cod, used to be the largest consumers of other fish. And in fact, in most ecosystems, fish are the major consumers of other fish species at various stages, whether they're eggs or larvae or juvenile or adults. And what happened with the collapse of, for instance, the North Atlantic cod was that it released the predation pressure of those large cod on smaller high-fat forage fish such as sand lance and capelin, which are actually preferred food items of some of the seal species, for instance, gray seals. And so those forage fish, those fatty, high-fat forage fish really flourished, which then supported the regrowth of for instance, the gray seal population after they had been severely, reduced due to basically killing and slaughtering and hunting. And if you look at the actual time period, for instance, when the cod moratorium on fishing happened, it was after the cod had completely collapsed. Gray seals were still at low numbers, and they increased during that entire period where cod have been collapsed, saying that basically our concept of how animals act in the ecosystem is really, really hard to predict. And the gray seals flourished because they had all their high-fat food that they could eat. And so this concept that one species in an ecosystem where there are so many predators, there are cetaceans, there's all sorts of whale species, there's sharks, there's large tuna and billfish, and other predatory fish that are eating other fish. And so to try and think of it as a single species predator affecting this huge multiple set of interactions is simply naive, and it's not going to help us manage ecosystems. It is simply not possible to know what the effect of a large cull on a given seal population or species would have on the marine ecosystem. As I have stressed before, the interactions are extremely complex. You could have the reverse outcome that you might have expected because the removal of a major predator could open up an opportunity for another predator, or it could allow some of the other predators, essentially, that predator preys on to prey upon the fish that you want to return. And in fact, there's been a long history in the last several hundred years of culling populations of seals and other marine mammals. And there has never been a documented outcome of success or knowing one way or another of whether it had any effect whatsoever. I think it's simply not possible to know, and I think humans have changed the ecosystem so much that to think that you could cull one predator and it would solve all the problems in fisheries, I think is simply not a good assumption. Hunting seals or other kinds of animals in a sustainable way for subsistence and food is a practice that is obviously something that has been accepted. We buy meat at the food market, we hunt deer, but that's a very different thing in my mind than a cull. A cull is something where basically you are slaughtering animals because you have some evidence that this will make a difference for the better of something else. And the fact is, there is no scientific based evidence that has shown that a seal cull would actually have the effect that is intended. And so I think to sanction something like a cull when you know that there's no evidence that it will be effective is irresponsible in the face, particularly of changing ecosystems with changing climate and all the other pressures that we have put on them. I'm interested in seals from a different perspective, in that I think they're an incredibly interesting animal that has adapted to a really unique lifestyle. And I think the point is, all the seals that are in these various ecosystems have been there since the beginning. There's nothing unnatural about them being in these ecosystems and being a part of the whole food web. And I think that we have basically messed the food web up and changed the ecosystem so remarkably that to focus on these small, tiny solutions or proposed solutions of cull of a single predator is simply to not recognize everything that's going on in the ecosystems, in the marine environment. I think the only thing we can do in the current state is to better understand what is going on in the marine ecosystem and what species movements and interactions are in the face of a changing climate, which particularly in the Northwest Atlantic is one of the ones that is changing and warming at the greatest rapidity. And I think using tools that we now have to both track individual species movements, spawning habitats, interactions, predation, we have to have better knowledge before we really try to fiddle with an ecosystem that we have already damaged so greatly.
Illegal fishing, anyways.
A variety of other factors.
Do you need me to go through all this?
No,
okay.
that's fine.
Right.
So I think the relative importance of pinnipeds on fish populations depends on a couple of key things. Number one, the size of the populations today relative to what they were 20, 30, 40 years ago, prior to overfishing. And the second thing that matters is the region or the area. And actually there's a third issue, and that would be the species in question, potentially. So with respect to the first point, populations, after they have become depleted, so they're much smaller than they used to be, by definition become more vulnerable to all factors that affect them. Whether it's climate change, whether it's fishing, whether it's predation by seals, whether it's climate change, small populations are more sensitive to change and all of these factors than large populations. So that's a key point, particularly from the context that many of our commercially exploited fish populations declined by 90-95%. So that has put them in a very vulnerable zone. Today, it's not so much to what degree are different factors responsible for the collapse of these fish stocks. We have a pretty good idea, pretty good assessment of what those causes were, and they were primarily overexploitation or overfishing. The key question today is, what is the relative importance of these factors on recovery? And I said it depends on the region and the different species in question. So off Newfoundland, the primary pinniped is harp seal, and many people are interested in the degree to which harp seals affect cod recovery. And I think one of the notable things that we've seen in the past decade is that while harp seals are at a very high level relative to what they once were, cod along the northeast coast of Newfoundland have been slowly increasing over the last decade. So we can't demonstrably or reliably or confidently say that predation by harp seals is negatively affecting the recovery of northern cod. It might be to some degree, but we're still seeing some recovery despite the fact that harp seals are there. So I would say that relative to other factors, seal predation on Newfoundland cod might not be as important as other things. But if we go to the southern Gulf of St. Lawrence, we have potentially a different situation. We have a different species of seal, the gray seal, a much larger seal, where populations have increased dramatically over the last 3 or 4 decades. Cod in the southern Gulf of St. Lawrence, so around Prince Edward Island, Cape Breton, the north shore of Nova Scotia, are at historically low levels because of overfishing. We depleted them, and at the same time the gray seal population was increasing dramatically. And today, I think it's fair to say that the best available scientific information indicates that gray seal predation is an important factor affecting the recovery of cod and potentially some other fish in the southern Gulf of St. Lawrence. So I think relative to other factors, it depends on the species of seal we're talking about, and it depends on the area, Newfoundland, Nova Scotia, Gulf of St. Lawrence that we're discussing. The southern Gulf of St. Lawrence, where we've got cod that migrate out to this overwintering area where they can be relatively dense. And as anyone who studies predator-prey interactions understands, is when the prey are comparatively dense, in other words, there's a lot of them per unit volume of water, it makes it relatively easy or easier for a predator to prey upon them. So the denser the school of fish, or the denser the aggregation of prey, the less energy that a predator requires to locate the prey and to then feed upon them. It's difficult ultimately to reliably and confidently estimate the percentage of mortality that one can attribute to different factors. So there's always some degree of error, some degree of variability in one's estimates and the confidence that one has in those estimates. But it does seem, again, the weight of the evidence, looking at estimates of mortality resulting from all of these different factors, does identify gray seal predation as a particularly important one. And I think there's also other good reasons for that behaviorally. And one of those reasons has to do with the fact that even though cod are at very low levels, the cod in the southern Gulf have a behavioral pattern that potentially puts them at heightened risk to predators. And what they do is in the fall, they migrate along the side of Cape Breton and overwinter off northern Cape Breton. So even though the total population size is relatively small, they can exist in a fairly high density in this small overwintering area and thus become potentially vulnerable to predation. So I think one must always consider the behavior of the prey and the predator when evaluating the relative merit of some of these hypotheses. Yeah, I think when people come up with estimates of how many tons of cod seals are consuming, it's more of a public relations issue, and it's not a scientific question. If you were, and the reason I say that is because if that was to be a scientific question, you would also estimate the tons of cod, in this case, that would be consumed by other fishes, by sharks, by fishing, by all other sources of mortality. It doesn't make a lot of sense to only estimate it for one source to the exclusion of others. So when people present that argument, I think they are advocating for a particular position, whereas someone who is not advocating for a particular outcome would try to present that information within the broad context of all of the sources of mortality that affect cod or other fish of interest. Some people wonder if seals were instrumental or a key factor in causing the collapse of our marine fish stocks. I would say the weight of the scientific evidence indicates that that is not the case, that overexploitation was the primary reason for the collapse of our commercially exploited fishes. We've seen so many examples of that for fish worldwide, that if harvest levels are excessive, populations tumble. So capelin is an important species. It's important for seals, it's important for humpback whales, it's important for pinnipeds, seals, cod, many fishes. Capelin have certainly fluctuated over time. We don't have extremely good methods to estimate the abundance of capelin. I think sometimes some people have presented information on capelin which suggests we have more confidence and more knowledge about trends in capelin than we actually do. We do know that the harp seal population has increased extraordinarily during a period when capelin were supposedly at lower levels. So certainly if capelin have been at low levels or potentially unavailable to cod, they presumably have been available to other species that depend on it. The other thing I would note is that it's certainly possible that one can have knock-on effects in a trophic system. You overfish one species and it has knock-on effects on other species, which could negatively affect recovery. But one of the things that we certainly saw in the Maritimes, in maritime Canada, is an increase in the abundance of herring and some other pelagic forage fishes after the decline of cod. And so it's not clear that cod were not recovering because of a lack of prey. I strongly suspect that the slow rate of recovery is simply a product of the life history of this organism, of this species in particular. We have unrealistic expectations about how rapidly stocks rebound after they've been depleted so dramatically. Secondly, I think we do underestimate the relative importance of fishing in some areas, not in the Southern Gulf, but I think northern cod is an area where fishing has remained an issue and continues to remain an issue. And with respect to seals, I think at some level they are a predator on cod. That goes without saying. And in some areas there's good theoretical and empirical reasons for thinking they're relatively more important to the survival of cod than in other areas. So the relative magnitude of these different factors again depends on where one is. I think the predictive capacity in an ecosystem framework is a fool's game right now. We cannot make predictions about what would happen if there was a cull of seals, for example, in one particular area. Heavens, we can't even make reliable predictions in a single species context. We have lots of data, for example, on the numbers of young cod or young salmon. And then we have corresponding data on how many adults came from those young 3, 4, 5, 6, 7 years later. And often we cannot find any strong relationship. Fishery science and biological oceanography is not a predictive science. For those who wish to make predictions, it must be one of the noisiest of systems possible, primarily because there are multi-species interactions. Yes, there are ecosystem models to try to forecast change, but all of those models have huge problems associated with estimating model parameters that reflect the link between predators and prey or competitors with one another. So I feel that going down the road of trying to predict how a multi-species system will behave when we tinker with one or two species is simply not one that will result in scientifically defensible or credible predictions. In Canada, there currently exists a framework, a management framework that attempts to govern these things. So as I understand it, with respect to the hunting of marine mammals, such as seals, there is what's called a limit reference point and a precautionary sort of target reference point that identifies population sizes relative to the maximum observed size, below which we do not want to go. So, at least in Canada, and I suspect the same thing exists in other jurisdictions, we at least have this framework that, in theory, should govern harvest levels relative to this sustainable policy framework for marine mammals. Now, one can discuss and whether the current framework is appropriate and whether the current thresholds are appropriate. But in theory, it's absolutely possible to harvest or exploit or fish a certain number or a certain percentage of a population of anything without endangering its long-term sustainability. And what fishery managers or scientists attempt to do is determine what those levels are where the long-term sustainability is not affected. Now that's always almost entirely in a single species context. Many jurisdictions have been saying that they are going to take an ecosystem perspective when determining quotas for different species. However, I think it's fair to say that most jurisdictions have quite a spotty record of accounting for ecosystem consequences, primarily because it's difficult to do. It's difficult to estimate quantitatively, but I think also there's still a reluctance to manage single species within a multi-species context. If the bycatch is too high of a depleted species in one area, then the fishing vessels cannot fish there anymore. They have to move. They have to go somewhere else where the bycatch is lower. Now, so again, one could argue whether the threshold of bycatch is too high or too low, but those kinds of measures certainly exist for some species. Is the monitoring sufficient? I think we can do much, much better. We could probably have video monitoring systems on all our vessels. I think that would increase the monitoring capacity tremendously. And I think recreational fisheries need to be monitored at some level. Right now, it's complete guesswork as to, for example, how many cod are caught in the recreational fisheries off Newfoundland. That's not just a Canadian issue, I should say. In Norway, where coastal cod are also caught in recreational fisheries, the government has no way whatsoever of knowing how many fish that tourists or recreational anglers catch. So this is a broad issue, not particular to Canada, but it's certainly an issue that demands and warrants strengthening.
What are the best ways to restore species that are endangered or threatened with extinction, or whose populations have been significantly reduced?
Well, I think the best way to deal with endangered species is to have a recovery plan, a credible recovery plan, to minimize all sources of human-induced mortality to the greatest extent possible, to identify targets for recovery and timelines for recovery. In other words, have a plan. Have a plan, stick to the plan, have the plan be one that is credible scientifically and reflects best practices for the similar species in other areas. And one should take all measures possible to ensure that the objectives of the legislation dealing with species at risk and the regulations and the policy objectives are actually met. So we need a plan, we need a credible plan, we need to stick to the plan, and for depleted or endangered species, that means keeping mortality by all human sources to the lowest levels possible. Well, I have to say that if one wishes to manage seal populations for the purpose of enhancing the recovery possibilities for depleted fish stocks, the one thing that one can do is to control catch. And that's pretty much the only thing that we can do, is to control catch. Sometimes you can control the size or the age of the fish that are being caught, but we can make decisions about catch levels, whether we have a directed or targeted fishery, or whether we have bycatch fisheries, so the species doesn't have a direct quota but is caught incidentally or by accident in other fisheries. But catch is the only thing that we can really control, either by quota or by gear type. In terms of, if one asks the question, are there management measures that we can impose on pinnipeds or on marine mammals to enhance recovery? I think it's fair to say that, again, the scientific evidence of where culls have taken place in the past has yielded no clear benefit or cost to such culls. And I think that underscores the key point I was making earlier, that it's extremely difficult, and I would say not scientifically credible, to predict what the ecosystem consequences, good or bad, would be from a cull of seals. We cannot credibly or defensibly make such predictions as to whether things will get worse or get better for any particular species. The question of whether harp seal abundance is sufficiently high today to weather the effects of climate change and exploitation, again, one would need to undertake some predictive modeling. There's no way to know reliably right now what a comfortable level would be, although I would say for many species, whether it's a seal or anything else, one of the best ways to withstand, or one of the best ways to ensure is not the best word, one of the best ways to hope that species or ecosystems will be able to withstand the effects of climate change is to restore diversity, restore biodiversity, and that involves allowing populations to recover to the highest levels that the current environment will allow for. So by increasing diversity, by increasing population abundance, you are increasing the resilience of the system to stresses like climate change. Okay, the key thing there is to have a sustainable fisheries policy and implement it, adhere to it, and I would also say have it informed by the best available science. In Canada, we have had a sustainable fisheries framework policy since 2009. And this framework policy has three key elements to it, and this is based upon agreements that Canada and many other countries made in the context of the UN in the mid-90s. The first thing is to have, for every exploited population, to have a limit reference point, in other words, a population size below which you do not want to go. You want a target, which is where you want the population to get to, and you have what's called a harvest control rule, which is a rule or a statement, a plan that determines what the fishing intensity should be depending on how close or how far away you are from the target. So in Canada, we have not identified targets for most of our depleted fish stocks. We do not have harvest control rules for most of our depleted fish stocks. We do have some limit reference points, this lower level, but we're not adhering to the policy. The policy says that if a fish stock falls below this limit reference point, that removals should be kept to the lowest level possible. So in a fisheries context, that would mean no targeted fishery. You do not have a directed catch or quota for that species if it's below its limit. But we have had situations, and we continue to have situations, where the government goes against its own policy. And northern cod off Newfoundland is a prime example. Over the last 10 years, where we have seen some positive signs of cod increasing in abundance, we have also seen the quota creep up in the inshore part of the fishery. Northern cod is estimated to be at less than half of its limit reference point. So it's not even at that limit. And yet, last week, the Minister of Fisheries and Oceans announced a 30% quota increase on cod. So how do we have sustainable fisheries? We have sustainable fisheries policy that is respectable, that is meaningful, that reflects best practices by other nations. We implement it, and we incorporate science credibly. In Canada, we have reasonable policy, but we're not implementing it consistently. Sometimes we are going completely against what the policy says. And another element is that, unlike the United States and unlike the EU, we do not incorporate science as strongly in our policy as those jurisdictions do. We allow for a much greater influence of the fishing industry in determining what the quotas ought to be. So we need a good policy, we need to implement it, we need to have science be part of that, and Canada has not been performing particularly well on those fronts.
Are Canadian fisheries managed competently currently, and have they been managed competently in the past 20 years or so?
Well, I think one measure of competency from a management perspective is whether populations have sustained catch levels or not. And clearly, Canadian fisheries have declined dramatically over the last 20, 30 years. So that speaks to deficiencies, weaknesses in the management system. Competency might be too strong a word, but clearly there were structural and procedural weaknesses in fisheries management that permitted overexploitation to take place. Are things better today than they used to be? Yes. We have generally controlled fishing mortality to a far greater extent than we did in the 90s, the 80s, the 70s, the 60s. So fishing mortality for many of our fish stocks, if not most of them, is under control to the extent to which our monitoring systems will allow. So that's a good thing. I mentioned earlier that we have the Sustainable Fisheries Framework Policy, which should guide the fishery management system when making recommendations to the minister, whether to open a fishery, close a fishery, increase the quota, decrease the quota. For some fishes, the policy seems to be working, but for others, vested interests still seem to hold a fairly strong hand. And as a consequence, I think that results in fisheries management not being as strong as government policy allows it to be, strangely enough. It could be stronger if it followed policy, but the whole system in Canada allows for other interests to have their say and to sometimes have their have their say take on a stronger degree of impact or relevance than perhaps is helpful. Fish farming, as far as we can tell, has no discernible influence on marine fishes. It might be having a discernible influence on Atlantic salmon, particularly in the southern part of the range in Canada, and fish farming, more particularly the interbreeding between escaped farmed salmon and wild salmon has already been identified as a threat to the recovery of endangered Atlantic salmon in the Bay of Fundy, along the coast of Nova Scotia. And so this is a threat that's been identified by Canada's National Science Advisory Body on Species at Risk, and it's a threat that's been identified by federal recovery strategies for Atlantic salmon in the Bay of Fundy. So if we're talking about Atlantic salmon, then yes, fish farming or aquaculture in open net pens has been identified as a threat to the recovery of that particular species.
Number one is harbor seals, stellar sea lions, California sea lions, northern fur seals, harp seals, or gray seals overpopulated.
Oh, okay. Yeah, so I don't think there's a clear indication that any of the species in Canada currently are overpopulated in the sense that they're exceeding their carrying capacity. Most species are still recovering from previous overhunting in the past. For example, gray seals are, and they haven't reached their carrying capacity yet. So in that sense, they're not overpopulated. They would be overpopulated if they exceeded their carrying capacity, and you would see that in that they would be malnourished and generally in poor condition, and then they would probably decline based on that poor condition back to their carrying capacity, which is the nature's way essentially of regulating a population. Research has shown that harp and gray seals mostly feed on small fatty fish that they need to build up their fat reserves for the winter. So these include herring, sandlance, capelin, and other small fish that are generally not of major commercial interest. So the overlap between the food spectrum for those fish and us is fairly low. And for that reason, we believe that harp seals and gray seals are not a major competitor for current fisheries. Specifically, the analysis of fatty acids in the tissues of seals has shown that the fat that they derive from their prey mostly derives from small oily fish like sandlance and capelin, for example, and not so much from larger fish such as cod that are of more commercial interest. Also, those smaller fish tend to be more abundant and easier to obtain for them than those larger fish, which are more scarce and harder to hunt. So for that reason, there's strong evidence that the food spectrum of seals on the East Coast, harp seals, gray seals, and so on, does not overlap very strongly with commercial fisheries. And that has been shown more generally to be true for marine mammals. Most marine mammals actually feed outside the prey spectrum of humans because they tend to focus on small forage fish that in most cases are not a major prey items for fisheries. That being said, herring, for example, is a major fishery in Canada. It's actually by volume the largest fishery. So the mortality caused on herring by fisheries, particularly here on the East Coast, is likely a lot larger than what is caused by seals, which are focusing on more abundant species such as, for example, sandlance. We also know from direct observation by putting cameras on seals that when you actually observe directly what they're foraging, it tends to be small forage fish such as sandlance, for example. Well, seals and sea lions are major predators of fish, and because they're warm-blooded like we are, they do consume fish. But the quantities they consume overall are probably orders of magnitude less than what's consumed by global fisheries. So I don't expect them to be major contributors to decline in fish populations. I personally am not aware of any documented example where a healthy fish stock was threatened by a natural predator to an extent that it would decline in abundance. Declines in abundance and collapses of fisheries typically happen through overfishing and the effects of climate, which can impact the recruitment or the replenishment of fish populations. Particularly where those two factors act together, we do observe collapses of fish populations, and again, I'm not aware of any documented cause where this was caused by predation from seals or sea lions. Seals and sea lions could have an effect on fish populations that have already been depleted by other means, for example, through overfishing or the adverse effects of climate change. So populations that are already depleted and maybe only existing in small pockets, particularly when they're highly aggregated. Intelligent predators like humans or seals or sea lions can find them and can deplete them even more. So in some cases there may be a conservation concern around that. But again, in most cases, that effect was not caused by predation in the first place. It was typically caused by the effects of overfishing, as far as we know. And I think also the reverse is true, that when natural predators are being culled in order to bring back a fish population, there is, to my knowledge, no documented case in the literature where this has actually worked. So that's almost the reverse argument. Has also to be true that when you remove the predator, the fish population does not necessarily recover, and I think that's mostly given in what we see in the data. Also, one problem with culling natural predators is that we're often not aware of the complexity of the interactions between that species and a whole variety of prey species, not just the species of interest that we're trying to protect. And often we observe these indirect effects that can arise when various prey sources are consumed and the predator is removed. Other species benefit from this as well, and if they're competitors with the species in question, the species of conservation concern, this can cause unintended adverse effects. So again, when we look at the literature more broadly, there's no documented case where the culling of predators had actually the intended positive effect in recovering a threatened population. If one was still theoretically to do this and was trying to determine the level of harvest or culling that does not have a strong effect on other species, one would need to use ecosystem models for that, which tend to have a high degree of uncertainty. I'm not sure this could be done in a straightforward way given current knowledge. I would say species that are abundant and in healthy populations can sustain some extra mortality. This could be intended or unintended mortality. Of course, a lot of these animals also die from bycatch and other sources of mortality that are human caused, but not necessarily intended. So we have methods for determining whether a population is healthy or not, or whether it's increasing or decreasing. A decreasing population, or one that is in trouble because of other factors such as climate change, for example, should of course not be harvested, and its mortality should be minimized. The harp seals have low breeding success in recent years because of sea ice condition in the Gulf of St. Lawrence. So this population is probably not stable right now, although I don't know the numbers. That would have to be determined. In any case, if the population is threatened by climate change or already declining, this is a reason to scale back or end the harvest, because this population cannot sustain any extra mortality because it's already unstable. The best ways to ensure healthy fisheries is to rebuild fish populations, which typically means controlling human harvest rates, which tend to be the largest factor that we can control that affects these populations. There is, of course, a natural ecosystem that sustains these populations. That ecosystem is changing. There was a report just out for the Atlantic by the Department of Fisheries and Oceans that asserted by observation that climate change is already severely affecting ecosystems in the Atlantic region and the Arctic as well. So we need to be extra careful. And when we try to recover or rebuild depleted fish populations, we cannot necessarily expect that they rebuild to the level they were at before, because the ecosystem has changed. Some people advocate to also control or manage predator populations to recover fish stocks. As I said before, I'm not aware of any evidence that this has ever worked or ever had the intended effect. Also, it tends to be costly and controversial. So I think doing what we know how to do, managing human harvest rates and other sources of human-caused mortality as well as we can in order to rebuild these fish populations to maximum productivity is what we should do. And it's actually what Canada has signed on to under the Convention on Biological Diversity and also the Sustainable Development Goals of the United Nations. So we already have a commitment to rebuild fish populations by controlling harvest rates, and that's what we need to do, and that's what we're already doing. We're already trying a lot in this space, and more can be done, particularly by addressing bycatch. Yeah, so species that are already threatened by extinction are of course a special case because they are hanging on by a thread. Of course, the first step is to reduce the sources of mortality that are human caused that we can manage, such as intended or unintended mortality through fisheries and bycatch, or others, like in the case of the North Atlantic right whale, by making sure they're not getting hit by ships or entangled in fishing gear. Typically, these are the major issues we can deal with. Other ecosystem issues are much harder to manage and control, but they are things that we can control and that we can manage, and typically we've had good success. This is why we have recovered many marine mammal populations from the brink of extinction, because we were able to control harvest rates and other sources of mortality and bring them back. But most populations are still recovering. They're not yet at the level they used to be pre-human harvest.
Hi, my name is Mike Murphy. I'm a retired fisheries biologist from the Florida Fish and Wildlife Conservation Commission. I worked for them for 35 years. My work entailed the study of the life history and population dynamics of Florida's marine fishes. Okay, single species assessments are traditionally used to determine the status of fish stocks. Some of their weaknesses certainly can be assumptions that have to be made about the constancy of things like natural mortality across time and across ages sometimes. A lot of these have been worked out and estimated for cod. However, there are other sources of uncertainty in terms of the amount of catch that's made, the relationship of the survey of abundance estimates that are used in the models to the true abundance. And all of these can lead to some errors in these analyses. The natural mortality issue, certainly in a single species assessment, can be complicated in a situation like cod and gray seal, where there is an outside force that's changing the natural mortality rate potentially over time, and if that's not correctly applied in the assessment, then stock status can be incorrectly determined. Now, more complex multi-species or ecosystem models would certainly need a lot more information on the predator-prey interactions between the various species within the model, their abundance streams over time, and their individual dynamics of every single one of the species. This is often difficult to do and also leads to a lot of uncertainty. However, it can uncover some linkages that are important to understand that would be missed by a single species assessment. For instance, if a prey species at a particular life stage is actually a predator of another species, for instance, there can be interactions that are not accounted for in a single species assessment and would bias those results. To my understanding, there has not been a multi-species gray seal cod ecosystem model that incorporates both the predator-prey relationship between cod and seals, and of course between seals and their other prey, and seal predators, and cod's other prey, and other predators. It would be a fairly cumbersome and difficult task, but it may allow you to understand the effects of gray seals on the cod stock abundance with greater accuracy. There's a lot of uncertainty in the estimates of the seal herd growth potentials. Those growth estimates are modeled based on pup production, sighting, resighting studies for estimating survival of adults, reproductive rates that are observed in the field. All of these have error associated with them, and the overall confidence limits on the estimates of abundance of seals can sometimes be quite large. Well, the uncertainty is associated with the confidence limits in the estimates of abundance. These are all affected by all of these other observations, like the pup production estimates, the reproductive rates for different age groups of female seals, the adult mortality rates. There are linkages in the model for most of the mortality occurring in the young of the year, so assumptions that are inherent in the model structure can create sources of uncertainty also, and those are generally reflected in fairly large confidence intervals in the average abundance estimates of gray seals. The gray seal herds have been increasing, but are likely to attract more and more predators, and as those predators reduce the population growth of gray seal abundance could stabilize or even be reduced to some level. Well, the separation between the northern and southern stocks of cod in the Gulf of St. Lawrence is not absolute. Certainly, old tagging studies have shown that less than 5% of the fish that they've tagged can potentially move from one area to the other. Vertebral counts and the statistical analyses of things like body part chemistry all are done with some error associated with the findings. So in the end, I guess the upshot would be that the Gulf of St. Lawrence Laurentian Channel is a barrier to readily interchange between those two stocks, but the two stocks have generally, the evidence is that they've maintained some coherence over time. If the northern Gulf of St. Lawrence cod stock increased in abundance tremendously, it is quite possible that there would be enough straying to contribute to the abundance of cod in the southern Gulf of St. Lawrence. The diet information for seals on what they eat in terms of cod is fairly uncertain. Gray seals are generalist feeders, and their feeding on cod varies quite a bit seasonally. It varies across the sexes, where males are much larger and take much longer feeding migrations, and it varies geographically. The generalist feeding of gray seals generally includes things like Atlantic herring, sand lance, flatfish, but also cod. And cod are an important part of their diet, especially for males, and especially during very specific times of the year when cod are aggregated and males are foraging in an area that is occupied by one of these aggregations. Gray seals are generalist feeders, and certainly their diets will reflect the availability of fishes in the water adjacent to their haul-out areas and in their feeding grounds. Females generally feed on smaller fishes like Atlantic herons that are closer to the areas where they haul out of the water, like Sable Island. Males will take longer migrations, and because of their larger size, quite often feed on larger fishes, and this can include the larger codfish. The ability of seals, gray seals, to switch prey is well known, and certainly as the abundance of other species, fish species, increases, they would likely include those more in their diet than when those species are at low abundance. Certainly, gray seals, being the generalist predators that they are, as I've said, would tend to prey on something that is readily available and give them the highest cost-benefit ratio in terms of how far they had to forage to actually acquire that prey. If a fishery on a alternate prey of gray seals is suppressing that prey's abundance, certainly some management of that fishery to reduce that catch and allow that alternate prey to increase could benefit the cod stock potentially by switching the gray seal's attention to that fish species. One possibility, however, is that if you allowed another prey species to increase in abundance, that prey species could actually, at another life stage, be a predator for codfish. For instance, occasionally when small larval cod are in the water, but there's a large abundance of Atlantic herring, which would normally be their prey as adults, the cods as adults, those Atlantic herring could actually be eating the small larval cod. So there can be a fairly complex relationship there that wouldn't necessarily be straightforward in terms of increasing Atlantic herring abundance to allow codfish to rebound. Certainly, cod has a long history of stock enhancement. Back in the 1880s, many national governmental agencies would embark on stocking fertilized cod eggs and larvae into the wild, all without much return. More recent advances in technology suggest that you can grow cod up to a large enough size where they have a higher probability of surviving in the wild. The difficulty will be the cost and, of course, the geographic scope over which you're trying to enhance a stock. The logistics would be difficult, the cost would be high, but it may be technologically possible. Many studies have investigated and measured the increase in natural mortality of codfish over time. This has coincided remarkably well with the increase in seal abundance, but other factors such as disease, parasite loads, predation by other animals could be considered a possible contribution to that natural mortality level. However, I think the scientific literature and research that's been done suggests fairly strongly that a good proportion of that increase in natural mortality is likely due to gray seal predation. There is evidence that cod in the Gulf of St. Lawrence have changed their distribution in response to avoiding seal predation, especially on their summer feeding grounds. I think there's less strong evidence in the winter, but this change in behavior by cod could lead to a reduction in encounters with gray seals and possibly a reduction in their natural mortality rate associated with seal predation. A criticism of this may be that this is moving cod into areas that are less productive in terms of their feeding on their prey. However, it's uncertain whether these other areas are actually less beneficial for them in terms of the amount of prey at the current time, especially under the current regimes of other fisheries being prosecuted in the Gulf of St. Lawrence. Cod that are either parasitized or weakened through disease would be more vulnerable to seal predation likely, or any cod that is in poor condition would be more likely available to seal predation. Gray seal management in Canada refers to a precautionary approach to management where a reduction below 70% of the largest seal population size seen is a floor below which you should not go to smaller population sizes. It also, within the management framework, indicates that a reduction to 30% of that largest population size would be a critical zone, and below it would be a zone where the stock has been damaged in terms of its biological capacity to sustain itself into the future. A cull of 50 to 60% of the populations of seals would drive the population to below this precautionary reference level. As with any population, if you reduce its abundance to smaller and smaller sizes, gray seals would become more vulnerable to catastrophic mortalities, such as epidemics or disease or chemical spills, that could potentially impact their ability to rebound and sustain their population levels post that event.